Hi everyone, welcome back to the Defender track. I'm Mohammed Farhan, a volunteer in the OWASP community, and I'll be moderating this session. During the next 45 minutes, you'll be listening to Laura Bell present team of 30 million, reducing software vulnerability at a global scale. Please submit any questions you have during the session in the Q&A tab. Just write to this video on the Hua platform. I'll be asking Laura your questions in the last 10 minutes of the session. Please note that the chat function in Zoom is disabled for attendees, but you can leave comments on the chat in the chat tab. A quick introduction about Laura. Laura has around 20 years of experience in software development and information security. She specializes in bringing security into organizations of every shape and size. She is the founder and CEO of the SafeStack Academy, an online education platform offering flexible, high quality, and people-focused secure development training for fast-moving companies. And she is like an experienced conference speaker, trainer, and a regular panel member, and has spoken in a range of events such as Black Hat USA, Velocity, OSCON. Yeah. She is a co-author of Agile Application Security and Security for Everyone. Welcome, Laura, to AppSec. Over to you.
Awesome. I'm just going to get my slides up. So good morning, good afternoon, good evening, wherever this finds you, whether you're watching it live or watching it recorded afterwards. I hope it finds you well. So just let's get these up and let's get this moving. All right, so the team of 30 million players. Now, hopefully we'll all be doing this in person very, very soon. And there's some amazing OWASP events coming up that you can join in with to do just that. But for today, we're still virtual. So we're going to keep this going the way we have done for the last couple of years. As Farhan said, my name is Laura, but I'm not here today to talk about what I do professionally. I'm here to talk about something I'm quite passionate about and something that you can join in with your team, your organization, whether your organization is thousands of engineers or just yourself. And I'm really very passionate about it. Now, a little bit about my background. I've done lots of things. My mom is very, very proud. But other than that, you don't need to worry about it. The reason, though, I put this slide up is because we all have a journey that looks like this, that has lots of different things in it at different times. And all of those experiences, whether they're in our personal life or professional life, they shape the way that we think about security. And in fact, this talk comes from something in most of our lives that shaped my thinking of security. Now, I'm going to have a caveat. I don't normally do disclaimers at the start of talks, but I'm going to because this is very important. I wanted to acknowledge that I'm going to use the COVID situation from the last 2 years as an analogy in this talk. Now, I'm not using that as humor. I'm not using it to lighten or to show disservice to what has been a really horrible situation for many, many people. But I think you'll agree by the end of this talk that there's an importance in drawing analogies when they are found in the world around us, because it can change the way we think. And so if we can use a bad thing to come up with a new way of doing something, then that can be a very powerful lesson. So please note, no offense is intended. And to those who have suffered any hardship or harm from the last few years, you have my complete support and sympathies. So let's talk about it, the team of 30 million. Whether you know it or not, there are 30 million, approximately, software developers in the world right now. And now, I don't know about you, but that number is mind-blowing to me. I can't really comprehend how many people that is. I'm here at RSA at the moment. You're joining me from a glamorous hotel room at 6 o'clock in the morning, where there are 27,000 people here. And for me, that feels like a huge number. So I can't really begin to imagine all of the software developers we have in the world. And it turns out that we're adding an astonishing 1.2 million of those a year. Now, if you also include software testers, that's another 5 million people. So that's a lot of people. Now, this got me thinking. Security has historically, we talk a lot about AppSec engineers and security specialists, and I've been one for a number of years. Many of the people who will watch this talk are that way. But what if, just, theoretically, instead of having, the team of a few thousand AppSec engineers globally, we could become the team of 30 million. Now, let me tell you a little bit of a story of where this came from. Now, I spend a lot of time with development teams, like many of you do, looking at how mature they are. And what I've discovered shouldn't be a surprise, really. It's that while we do talk a lot about some of the very cutting edge teams, the Netflix of the world, who, on the very, very bleeding edge of technology, they're doing AppSec at speed that most of us can't comprehend, that only represents 2% of our global population of organizations. The rest of us in what we call fragmented exploration or emerging, which means that we're trying to do stuff or we're not sure where to begin. And that's okay. Now, what's this got to do with the team of 30 million? Well, if we all focus on just the cutting edge companies and what they're doing and hope that it helps our ecosystem, then we're missing opportunity for this massive collective of organizations to contribute together. And in this talk, I'm going to show you how to do it. But let me start with a bit of a story. It was April 2020. Like most of us, the world was shifting very, very rapidly. And in New Zealand, where I live, that was no different. We were about to enter a lockdown, like many of us did in that period. We were learning about pandemics firsthand. Now, even if you've read about them before, there's something about living through one that is very different. And we started learning about infections and N numbers. And I remember sitting there, maybe perhaps it's just part of being a security person that you see it in every situation and you see security problems, you just can't help it. But I remember sitting there and looking at what people were talking about contagious viruses and going, so if one person is sick and they spread it to 2 people and they spread it to 4 and so on and so forth, this looks a lot like malicious software. This looks a lot like viruses and malware. We've seen this before. Now, while most of my family were happily embracing making sourdough or doing whatever else you did in the pandemic, I started thinking, well, if we looked at how we respond to a pandemic, are there parallels we can draw in information security that would allow us to change the way we do it and perhaps protect large populations of people? Now, why am I thinking this? Well, it's because whenever you have something that's a shared human event, you automatically have a language that translates between large groups of people. This does what we call reducing cognitive load. So it makes it much, much easier to understand the concept because people already understand the foundations. So there's an opportunity there. Now, what I noticed was in New Zealand, we actually had a 5-stage approach to managing COVID. Now, I don't think anyone really called it this 5-stage approach, but when I started looking at it and pulling the data together, there were 5 steps we were taking. And those 5 steps, it turns out, are things that you can take into your organization. And if we take them into all of our organizations, then we can actually start protecting applications on a scale we've never done before. So let me walk you through it. Now, just a bit of a kind of take-home thought for you. I'm going to outline 5 different methods here. And they can apply to companies that have no resources in their team and equally to big companies that have massive resources. Pick the bits that work for you, because the thing with sharing security responsibility or collaborating in security is it's not about us all doing everything and spending $1 million each a year on security. It's about every little step we do as a combined population coming together to make us all safer and more secure. So let's get stuck in with the first stage of this. That's what I call tracing. So tracing, what was it in the COVID sense? Well, in New Zealand, like many of you, we had an application for contact tracing. So the idea in the COVID sense was if somebody was infected and they were getting sick, then you wanted to contact all of the people that they have been around so that you could warn them that they might too be getting sick, and so that they isolate and take steps. Okay, great, fantastic. So we have the routing in where it sits in the COVID world. So how do we, as security folk, as developers, adapt this to be part of our world? How can we use tracing to protect global software? Well, there's a thing with how we approach securing our products at the moment. Now, I code as well as being a security person, and I have a team of people I work with to build an education platform. So that's awesome. But it's very easy, and I do it myself, to see yourself as the center of the universe, much like we did, back in the very, very olden days, where we didn't really understand how the planets worked and how things rotated around the sun. We thought, we were the center of the universe. We were the most important thing there was, the only thing to focus on, in fact. Tracing encourages us rather than think about ourselves as the center of the universe, but to consider our position in the universe. Now, this here is a picture that I've taken from Anne Vanker. Now, this QR code you're seeing on screen will take you to this page itself. So please don't worry, I'm not going to rickroll you. I'm not that person. But I'm showing you because it's a way of visualizing the universe we sit in. So Anne Vanker, in this case, is visualizing the connections between the Browserify NPM package and all of the other packages it connects to. So by connects to, it means they inherit from or are connected to it by other code. Now, you may install Browserify, which will be, several tens of lines of code. But in fact, by doing so, you end up connected to an ecosystem, and all software is like this, right? We don't build everything from scratch anymore. If you're that person, that's cool and all, but it's quite an inefficient way to build software now. We're all used to the idea that when we build code, we bring in other people's code to augment it, to do those functions that it's not worthwhile us building ourselves, or in some cases, it's not safe for us to build ourselves. For example, cryptography. We've been saying for a very long time, use good quality components that you can trust because, well, that makes you more safe and secure. So what does this graph and this universe have to do with protecting our global ecosystem? Well, firstly, let me clarify, this isn't about Node, because there'll be at least one person who watches the video who goes, oh no, she's going to rant about NPM. That's not true. This is a picture from libraries.io. Now, I love the team at libraries.io and what they did. They've basically become the librarians of package managers. They can tell you where all of the packages are in the different ecosystems. Now, NPM at the top corner there has 2.3 million packages. That's quite a lot, you'll have to admit. But the average package length, there's about 10 lines of code. So there's lots of them. They're very, very small. If you're in something else, say you're in Maven or you use NuGet or you're in the Python space and using Pippi, you equally have hundreds of thousands of packages at your disposal. Now, when we start looking at contact tracing or tracing in our software ecosystem, it's all about understanding how we relate to the packages that our software is made from and the software our software is made from. This gets quite confusing, but let me go a little bit further. What we're talking about here is what we call transitive risk, the risk you inherit from those connected to or successive members of the sequence. So if I use package A and package A uses package B and package B uses package C, we're all connected and related. Now, in some circumstances, not all, but in some circumstances, you can inherit risk from package C, even though you're 2 steps removed from it. And this is much like the human risk we learned about in COVID. By being connected to people and having those interactions with them, we can find that security vulnerabilities come our way. So how can we manage transitive security risk? What does it mean for us? Well, we have to draw our own graph. Much like Vanker does it for NPM, we have to figure out what we're connected to. Now, in some custom environments, that might be really straightforward. You just pull your package and dependency list, fantastic, job done. But for many of us, that's not the case. Now, if you're an environment that has grown over a number of years, your dependencies probably doesn't include one ecosystem, it might include many. It may include components that were built years and years and years ago. We call these a legacy or foundation components. Now, you might not have a package dependency list for those because, well, they may not have been built in a long time. You might find that while you know what you build from, each of those components that you build from also has its list of dependencies. And so you end up with this big graph. So nodes and edges, where you're visualizing how much of the world's software you touch with your simple application. And the more complicated and more densely interconnected your application is, the more impact that ecosystem has on you. So you start to feel the real visceral impact of the software development community that we live in. Now, why this matters is what we would call in a security space a supply chain attack. Now, supply chain attacks in security have been gaining a lot of press. So whether you've seen SolarWinds or you saw the Log4j vulnerability, you may not think of them as supply chain attacks, but they are in the sense that they are used by many applications and organizations. And as such, when they are compromised, the ripple effect through that transitive vulnerability, that transitive risk that we've talked about is huge. Now, if you were affected by Log4j, you will know this because you probably had some work to do that day. But if you were not, if you're using a different ecosystem or language, you may not have experienced this firsthand yet. Supply chain risk is increasing, and it's going to increase a lot more. And I'm going to explain why. I want to use Heroku as an example. Now, if there's anyone from Heroku or using Heroku that is watching this talk, please know this is not about a criticism in any way. You just happen to be in the press at the moment. So I've been taking my stories and statistics from very recent events. And I have to give my support and kudos to all those involved in the current activities going on there. Now, Heroku have recently undergone a nasty supply chain attack. So they are, if you are not aware, a platform as a service organization. So they allow you to roll up, spin up applications very, very quickly in their hosted infrastructure. They host at the moment, and this is taken from their website, 13 million applications and have 9,000 paying customers globally. Now, if you're an attacker, you are fundamentally quite lazy. Now, I don't say that in a bad way. Lazy in the sense that why would you attack 9,500 customers or 13 million applications independently when you can go after a shared component? Now, that shared component could be a library or it could be a hosting provider. In this case, it's a hosting provider. Now, just 3 of the case studies literally taken from the Heroku website, the types of applications that are hosted on that. So we have GoToMeeting. Now, in the world of pandemics, having access to video chat software has been pretty important. So there's some sensitive things happen in software like that. We have a DNS provider. Now, it doesn't take a lot of imagination to see what you would do if you were able to compromise a DNS provider. You're literally rerouting the traffic of the internet. Now, depending on what that DNS provider is providing the records for, it depends on how important that attack would be. And then we have a medical company. Again, all of these are by no fault of their own. They chose well, they chose a technology they trusted, but a compromise happened in the supply chain, and here they are, they're being associated. Now, just to repeat, none of these companies have done anything wrong. I'm not saying they're vulnerable today. Their incident response teams will have been over this for a number of weeks and months. However, it makes you think. It makes you think of the power of that connection and the vulnerability we inherit from it. Much like in COVID, where we were vulnerable because as people, we're connected to each other and we interact with each other. In technology, we inherit the same risk. So we have to come up with a way that we can contact trace or understand those risks that we inherit from each other. And it starts at the very beginning. It starts with us choosing our software. I've just chosen a package at random. I literally went to Google and I Googled for open source crypto library. Fabulous. Now, many of us have chosen libraries in the past. Of course we have. And I'm going to be really honest. Many of us don't use a particularly mature framework for choosing those libraries. You know, our first concern is, does it do the job that it says it's going to do? And then many of us will look at things like, well, does it have lots of stars? Or are there lots of people using it? So contact tracing starts with understanding the technology we use. The technology we use starts with choosing the right things. So how can we make sure that we start contact tracing efforts by having a great, really well-defined list of software we can trust to begin with? Well, we could have an open source evaluation set of questions. Now, all of these slides will be shared afterwards. I'll be releasing a white paper free of charge that will have all of these questions in, so you can go and use them in your teams. But these are the questions that we need to start asking about every single library and framework that we do. Now, no tool is going to do this for you. I would love to say there was going to be a tool that solves your problems. There isn't. There are tools that will help with part of this. So, for example, the OWASP dependency checker, where it's going to tell you, are there known vulnerabilities? That's a great project. If you haven't used it, you should go check that out. But other things we should look at, is the code fresh? Is there active contribution? Is it regularly released and maintained? Does it have existing issues, not just in the security sense, but in the functionality sense? And how frequently are they found? What is the project culture? Is it a great safe place to share, or is it a bit of a toxic mess? You do all of this internally. If you were a colleague's code base, you would be looking for these just naturally. It's time now that we start looking for them in an organized way when we take in open source libraries and software. Now, the keynotes we're facing then is we are understanding that we're connected to lots of other libraries and frameworks. and they are connected to other libraries and frameworks. And much like we did in COVID, we understood our risk via contact tracing. Understanding that graph that we sit in is really key to understanding our exposure and risk, because it's step one of identifying if something bad has happened. If you know that a component in your ecosystem has been compromised, you can map out if you're likely to be in harm's way too. Choose your technologies consistently, and then you're able to understand that you know you've chosen really good technologies to start with, and that you've considered risk to begin with. Now, that's not to say that there won't be risk in the future, but there will be at least a little bit more to stand on. And keep up to date with security news so that you can know when you need to respond. Now, speaking of which, let's move on to our second stage. So our second stage is what we call distancing. So distancing in the COVID times, let's talk about that. Now, these posters from New Zealand, your countries will have done different things, but we had all of these around, they were everywhere. You couldn't walk without seeing a yellow poster. So wearing a face mask to keep your mouth and face physically distant from other people's, liquids, let's call it that. Staying home if you're sick, keeping at least 1 meter apart or 6 feet if you're in the US. All of these were very, very important to help us reduce risk. So what does distancing mean in our software? Well, this is where we start talking about architecture. Now, if you're a software developer, you may not have ever considered yourself an architect, but you really are. And sometimes the way that we separate software architecture from software development has been a little bit dangerous. In software, an architect isn't just somebody who designs the system passively, it's also somebody who supervises its implementation and makes sure we're understanding the connections between our elements and planning them in such a way that the risk is reduced. So how can we use our knowledge of software architecture and social distancing to create safety in our applications? Well, firstly, let's understand a little bit about basic architecture. Our applications no longer look like this. We very rarely now have a hard external framing, which contains our soft, squidgy, very vulnerable and valuable middle. Most of our applications don't even look like this anymore, where we have polite components and we know where they are and what they're doing. Most of our applications grow very fluidly and very fast, and they spread out. Now, in COVID times, this also included a lot of applications that suddenly went online or suddenly were exposed to other sources because we weren't physically in an office anymore. Distancing is about understanding how our architecture has been built and how we can put controls and barriers in place between elements to prevent risk. Now, I'm going to use a really simple example. It's not even using technology, so forgive me for that. But there's a reason for that. Firstly, it's 6 o'clock in the morning. Secondly, it's because sometimes you need to take it away from the tech to really kind of find your grounding. Let's talk about bears and honey. Now, obviously, bears do like honey. They like a lot of other things too. But let's use honey in this example and assume that your application had the equivalent of honey in the middle of it. And your attacker, which is our equivalent of our bear, is really going to be keen to get hold of that honey. Now, distancing in our architectural sense is putting controls between our bear and our honey that's going to prevent the bear from getting it. Now, those could be preventative controls, so putting a bear trap in the way, for example. It's going to stop the bear because if the bear happens to spring the trap, they're going to get hurt. But there's a problem with this, and we can't just put bear traps, and that's because if you cover the entire floor in bear traps, well, you're not going to be able to do much in your environment anymore. And it's kind of like security, right? If you put too many security controls in, it becomes a little bit unworkable. And there's a balance between the number of preventative controls we can put in place and the effectiveness they're going to have. So as well as preventative controls, we put other controls in. So things like detective controls, ones that are going to spot the bad things that are happening and tell us. Now, we balance out having a mix of these preventative and detective controls so that our ecosystem, in this case, our pot of honey, is protected in a layered way. So that if one thing fails, so our bear trap doesn't trigger, then we'll spot it quickly and we can trigger our honey incident response plan. Okay, I'm stretching this analogy far too thin now, so let's carry on. What we're talking to, and goodness me, I never thought I'd say this in a talk, is zero trust. Now, please don't worry, I'm not here to sell you a magic box that's going to do zero trust. I'm not going to sell you anything in this talk. Zero trust, though, is the idea of trusting nothing, assuming every element of your system can be compromised, that nothing is supposed to be there, and acting accordingly. Now, in our bear situation, that means that we don't assume there won't be a bear. Now, the likelihood is very low that there is going to be a bear in your environment. And to be honest, it's very low that chance that the thing you're protecting is a tub of honey. But there is a chance. And if it happened to exist, then you could implement an environment that meant I'm going to protect against bears, even if it's very unlikely to happen. And we can choose in application security to use a range of controls in our environment as architects, as software developer architects, to protect what matters most. Now, distancing in software is about the layering of these controls to create barriers between our sensitive elements, not to stop things, not to slow things down, but to ensure that everything that is there should be there, and that everything that we're doing, we understand and that we validate and on each occasion. You should be familiar with many of these controls. I'm not going to dig deep into those today, but you can use this slide later as a reminder, so you can go digging into these things if any of these concepts are new to you. Now, this diagram here, I really like, and do you know why I like it? Because it comes from OWASP, but a bit of the OWASP space you may not have encountered yet. This is from the Threat Assessment Cookbook, which is a really amazing group of free-to-use software design patterns for security. Now, they've been contributed to by a range of organizations, and the repo is growing. But what I like about them is that they outline structures and architectural structures that will distance and separate your components from each other in logical ways, which preserve the integrity and functionality of your system, whilst also allowing you to get the job done and protect things. So this one here is for payment systems. If any of you are watching you build payment systems, a lot of this will seem very familiar. Using these design patterns can be a really great way for you to start looking at your architecture and comparing. Now, I don't mean you need to have a pretty architecture diagram that you built in Visio. I mean, draw it on a whiteboard and look at these design patterns and go, okay, does this work? Is this what I'm doing? What have I done that could be changed? What we're talking about here is threat assessment and threat modeling, and we have some wonderful resources in the OWASP community and beyond that you can go check out on this. The idea being is I want you to give you and your team permission to bring this to your everyday practice. I want you to look at the architecture of your built components, not just the code and the syntax, but how that all fits together in a structured way. Now, some of the resources you want to check out after this. So OWASP Threat Dragon, its cute little logo is here on the screen for you now. The Threat Modeling Cookbook that I've just mentioned, and the Threat Modeling Manifesto, which is not part of OWASP, but many of the members overlap. All of these are going to give you a guideline of where to start with distancing, keeping your application architecture separated and protected using layered controls to ensure that one element is protected from another. So how to get started with distancing, your 3 steps to success. So design for security. Even if you think you're just a software developer, I don't, there's such thing as just a software developer, but you are also an architect. So consider the architect of how all your components fit together. Embrace zero trust, but not in the hypey way. I don't mean going and buying something, please don't go and do that, but embrace it in the way where you're separating components and that you're trusting nothing in your architecture, so that you're making and taking steps that will allow you to make good choices all the way through. Then make architecture a team sport. Use the tools provided by OWASP and others to do threat assessments, to look at your architecture in a new light. Next up, testing. Now, testing should be familiar. That of all of the concepts that COVID has introduced that we already knew about, it should be testing. Now, testing is very important, right, in COVID times. It told us we were sick. It told us when we were contagious. This is one of, again, our posters from New Zealand. We had a list of symptoms, what we would look for to know a bad thing was happening, and then a response we would take. In this case, go and get a test and then stay home. So how does this work in our software development lifecycle if we were to apply the same thinking of COVID to our lifecycle? Well, firstly, we need to get over the idea that testing only happens in one place. Now, I haven't done it as a traditional circle here because, well, you can imagine it as a circle. But all of the steps are the same. We've been teaching the same concept now for 20 years. And testing is always listed at the end. And I always find that quite sad because I actually think we should be testing and validating all the way through. But I guess it wouldn't be much of a life cycle. If everything was at every stage, it becomes a bit like the multiverse. So where can we fit testing in, and how does it work to protect our entire global ecosystem? Well, the first thing we want to do is understand that there are many types of testing, many that we're overlooking on the whole. I'm not here to talk about penetration testing today. We've talked about that a lot. There are dozens and dozens of talks out there about the importance of penetration testing. But to be honest, I want us as a community to make penetration testers work really, really hard. I want to make them quite upset. To pen testers who are watching, I'm really sorry about that. I love you. What I want us to do is to have done so much testing before they get involved that we do make them sweat, that they don't have to look for low-hanging fruit. Now, we can do this in two ways. The first is vulnerability scanning. So the idea that we look for common signs that something has gone wrong, and we can then go investigate those further. Now, in COVID land, that is the equivalent of you having to have your temperature checked when you go into a store, which happened very commonly in New Zealand. Now, will having a temperature check tell you if you have COVID? Absolutely not. But it will tell you're sick, because if it shows you've got a fever, there's something wrong. You get a fever when you're unwell. So vulnerability scanning is the equivalent of getting a temperature check. It's looking for one symptom that could be linked to many problems, but it's telling you need to go investigate further. And we can put vulnerability scanning throughout our application, whether we're scanning the as-built application in our production environments, or we're scanning in the build pipeline as part of our CI/CD. The other side of this is automated testing. So where vulnerability scanning is looking for symptoms that could mean you have a vulnerability, automated testing is looking for a very specific combination of symptoms that could confirm a very specific issue. Now, it takes a lot longer. Running a vulnerability scanner is find a tool, put it into your lifecycle, hit go, deal with the report, do a little bit of tuning, but automated testing requires us to write tests. Now, in the COVID world, this is our PCR tests, our RAT tests, but in our software world, that's something different. These are tests that we could run manually. So if you have not embraced automation testing yet, I'm not judging. I know that happens. But you could build manual tests or run tools that check your packages for common security vulnerabilities. You could do that today. You could build a separate testing pipeline and build automation tests that run alongside your main CI/CD pipeline right now. Or you could integrate them into your pipeline. So if alongside you writing your functional unit tests, for example, if you're in the Java space with JUnit, you could write security tests alongside. Now, there's been some amazing talks on this. In fact, one of the reasons for this talk is to kind of draw your attention to some amazing things that already exist that we're not using in a coherent way. So while there hasn't been massive adoption of things like BDD security and Mitten, they were really, really good examples of how we can use automation testing languages and Cucumber style frameworks to hook into security tools and put them in our lifecycle. Now, admittedly, they take a lot longer to run than some of our standard tests because they're hooking into big scanning frameworks in some cases. But it's an opportunity to put security testing exactly where it needs to be in your lifecycle, and that's frequently done with every commit. Now, some of you will be looking at this going, well, it's okay. I've moved my testing out to a parallel thing because it was too slow. It slowed down my CI/CD pipeline. And so I've had to move it out and we bring it back in at the end. If that is something you're doing, I want you to make sure that you are really understanding what happens, because when you take testing out to the side, in COVID terms, it would be the equivalent of you doing a COVID test and then just going about your business and just, okay, I'll wait for the result before I decide what I do next. Now, that's not a great idea, because in that period of time between taking a test and getting the results, you could find out you could actually be contagious. So you're going to spread harm. When we do parallel testing, we do the same thing. We've taken the test out and we feed the results back in later, which means those results come back in after the code is completed. In fact, in some cases, a couple of weeks after the code has been completed. That's really difficult for them to go back and revisit that code. You want to take the action straight away after the test. So keeping it integrated in your pipeline is really important. When you're choosing a tool, for example, a dependency checker, so going back to my recommendation of using OWASP dependency checker or any of the many tools that are available in that space, here's a list of things you want to be considering. Does it support the language and ecosystem you use? What kinds of vulnerabilities can it detect? Because not all scanners can find all things. How accurate is it? And how many false positives will it give? Does it work with binaries? Now, I'm asking this very specifically because there are many of us who have components in our ecosystem that we only have the binaries for. Perhaps it's a binary that we've inherited or we include because we're using it as a dependency. Does it integrate with your IDE so it can come close to you? How hard is it to use? How painful? Does it work continuously or automatically? All of these are super important. So again, this checklist is available afterwards. You can bring this in whenever you choose a new testing tool to make sure it's going to fit your circumstances. So how can you get started with testing, which is phase 3 of our approach to global security across all of our dependencies and the team of 30 million? Firstly, automate your dependency checking. So use OWASP dependency checker and get that stuck in today. If you have another tool that's already doing this, make sure it's turned on, make sure it's enforcing, because I find many organizations have these in and they never get configured properly. So go check. Consider your legacy projects. Now, the problem with automated testing and with dependency checkers is that they only run if they're integrated into your pipeline when the pipeline runs. So if you know your pipeline doesn't run anymore because that software is under active development, then figure out what you're going to do about that. Make sure that you're building it occasionally, or find out alternative methods for you to consider and look at your legacy projects. While the code in your legacy projects may not have changed, and therefore it's going to do the same thing it did at the start, the attack ecosystem is changing all the time. And so it's important we revisit old tools with new eyes when we understand about new tactics for attack or new vulnerabilities that have been found. Finally, make it break. So there's no point in running a vulnerability scanner or automated testing if you're not going to listen to the results. So make sure your testing has the power to break your build. And if you know that you've been putting exceptions in place and just going, well, I'll come back to that later, stop, take a breath and let it break, because it's really important we're fixing these things. One small low criticality issue combined with many other low criticality issues very quickly becomes a serious problem. So make it break and fix them now rather than saving it up for a lot of work later. Next up, prevention. Step 4 of our approach to the team of 30 million. So again, with our lovely posters, now I'm going to call out the artists who are involved in these. I thought they were nice to wander around. If you're going to have posters everywhere, at least they're friendly. Prevention is really important. Now, prevention in COVID is about vaccination. I'm not here to talk to you about that, but that's what it looked like. Prevention in software, though, is something completely different. Prevention in software is about updating and patching. Now, I'm not here to tread the well-trodden ground of you should patch your stuff and you should patch it regularly. You know this. We know this. But if you were to raise your hand right now, if you had a package in your ecosystem that you knew was out of date that you're still using, I'm certain that almost everyone who watches this talk would say yes to that at some point. And that's because there's many reasons why that happens, and it's not just laziness. Sometimes it's laziness, but mostly it's not. Let's talk about some reasons why that happens and why prevention is more than just patching. So there are 3 common scenarios where we can't update our libraries, where it becomes difficult. Firstly, it's a legacy project. They may not make libraries and patches for your system anymore. I work with a range of organizations all around the world, from giant banks to tiny nonprofits, and many of them use software that there's nobody around that supports it anymore. In some cases, those coders, those developers are long retired. So we can't just go in and patch that stuff because this system is fragile. It is vulnerable in a different way. Sometimes we can't update because, well, security changes aren't put in on their own in a patch update. Often they're bundled with functional updates. So while you may want to fix the vulnerability in the code, you don't necessarily want to inherit all of the changes to functionality it's going to bring with you. We call that a breaking change. So what do we do then? Because you can't suddenly miraculously make your team available to do 2 weeks of work just because you need a security update. It could be there's no patch available. Now, it's unusual and patches do come with time, but if you're using an open source library or framework that hasn't got a big population or that is not particularly security experienced, and I say that with no judgment at all, then there might be some patches that are available some time. We have to have a plan as a community for what we can do when we can't patch. Now, this is the equivalent of my situation at home. I care for an 80-year-old. She's very, very vulnerable. And so getting things like vaccinations for us is difficult because she has many conditions that makes that a little bit more challenging. We had to have a plan as a family. How do we protect her when she can't be protected in typical ways? Same in software. How do we do this? Well, we start identifying the projects and the libraries that we know we can't update easily, and we have a plan. We do something else instead. So what are our options? Well, we can fork and fix. So if it's an open source piece of software, you can take it, you can fix it yourself, put it in place. The problem with this is that you've now created another problem for yourself. You've taken this outside of the ecosystem and is now in a space whereby it is not going to be able to get updates from the main trunk. Now, that's a problem, right? Because you might have solved one problem, but you're now going to inherit more later. You've taken long-term ownership of that piece of code. Now, ideally, we would all contribute back and we'd all push that upstream to the open source project. But there's many organizations that don't let us do it. If you know your organization is one of those, then perhaps that's something you can go and push with after this talk. Go and ask if you can push changes back upstream. Or you could ignore it. Yellow. What's the worst that could happen? No, please don't do this. This is a terrible idea. But we could, and many people do. Or we could change library. You know, let's just choose something else. If we know there's a problem in React, let's choose Angular. If we know there's a problem in Java, oh, let's become .NET developers. That's a bit extreme. Let's not do that. But we could do. Now, the problem with changing library in this way as a solution to our problem with vulnerabilities is that we have not necessarily solved the problem. We may have just inherited new problems as a result. We inherit problems in this situation, such as key person risk. So, for example, if you're moving from an established technology which has had a string of vulnerabilities, so for example, you're moving from a WordPress project to something home built. Yes, WordPress has a lot of vulnerabilities, but there's a lot of people in the world that understand how to keep WordPress safe. If you move to your own custom stack or something more obscure or edge case, you might find there's very few people who can help you with that. And so there's a trade-off here. When we're protecting libraries that cannot be patched, and we decide, well, instead of using that, I can't patch it, I'll choose something else, you might introduce a human risk. I want you to reduce human risk by letting people have holidays, let them have time off. Don't change your libraries to technologies nobody else can support. It's going to hurt you later. So how are we going to do this? Well, we're going to look at edge cases. Find all of the components in your architecture that you don't build, that you don't have the source code for, that were written by an intern in 2006 and nobody knows where that code went. Find the things that you can't fix with GitHub's Dependabot or any automated patching tool, because there's going to be lots of them out there. Our current modern tooling is built for the top 5% of applications who can run it. The rest of us, we have a lot of other challenges. So find your edge cases and know what you're going to do, whether it's you're going to fork and fix something, whether you're going to ignore it, whether you're going to layer some other controls and go back to our distancing approach, or whether you're going to monitor really, really closely. You have to do something. So here's your top 3 things you can go and do straight after this talk. So you can define a patching policy. Define it very concisely and preferably as code. Now, defining it as code is a step forward for many of us, but you can do this. Set your containerization, set your infrastructure to have patching built into its cadence. Set it in your build pipelines to automatically build and patch if you can do that. Automate it where you can, because people like us, we're busy and we're going to forget. So make sure that you don't take any chances and risks. Make sure that your automation will do it for you when you can't. And then most important of all, I want to talk more about the software that we cannot patch. The software that we can't use modern dependency checkers on, the software that lives deep down inside our ecosystems, that is underpinning what we do. And let's make a plan for that, because it's exceptionally important. So finally, response. Now in COVID response, we had isolation. You went home, you stayed home till you were better, you took a test. Now, you might also be notice that we have other incident response plans we see day to day. So this one I've taken from Air New Zealand. You're used to seeing incident response plans in all parts of your life, but incident response and security often just lives in the security team. I want us to move past incident response as being just in the core network security team or in your global security team, to being a repeatable process wherever you are in the organization for assessing and responding to unseen or unexpected events. Now, I want us to start building application security and application development incident response plans. I'm going to explain why. Incident response is just a repeatable set of steps that we do every time something bad happens. There's nothing fancy. It starts with identifying there's a problem. So how did you know that a bad thing has happened? Verifying that it is indeed a problem, containing it so it can't spread, and then responding to fix it. So in COVID, that would have been identifying it. I have a fever, I feel unwell. Verifying it, taking a test to confirm that, containing it by staying home, and responding to it by treating the symptoms of having a fever and staying there until you get a clean test in your verification stage, and then you go about your business. So why do we need to do this in application development? Well, there are situations in application development that will not fit into your organization's response plan. For example, what if there was a scenario where an account has been compromised in your application? That could be through a technical vulnerability like SQL injection, or it could be an account compromise like password guessing, or brute forcing, credential stuffing. Now, in that case, you do need to do a few things. You need to get together a team and you need to respond in the application security sense. Now, this is not something your network team can respond to. They don't understand. It's going to be passed straight from the people who report it, normally in your customer success team, straight through to your developers. So they need a plan. Now, creating this plan is quite good fun. If any of you like me are a bit of a nerd, it's a bit like D&D. You gather together your team, you plan for your scenario, you then test your scenario and you learn. So in the case of our compromised password, you gather together not just people from your application development team, but security folk, perhaps even your customer success team. And you go, right, what's happened? Well, somebody has rung in and they've said my account has been compromised and there are suspicious transactions. And you work through what you would need to do as a team. What logs would you need to find? What information do you need to have available? How do you verify this? How do you check that it's a real thing? And how bad is it? Is it one account or is it dozens of accounts? Has it happened just once or hundreds of times? And all of this is going to help you understand what you need to do next. Then we're into containment. So do we need to lock out that individual's account, cut all access? Do we need to do it over multiple accounts? All of this is very application specific. This is not about your network and beyond. So have a plan in your team. Next up, remediation. So do we need to fix it? Is it user error? Did they choose a poor password or a password that they used elsewhere? Or did we let them choose a poor password? Or did our authentication system fail? All of these things have different types of outcomes and remediation efforts, so document those. When you run your test, do it in a safe way, but don't just read the document and go, oh, yep, looks like a document. I want you to get together and really walk through it, get the data you need from the logs, get the conversations going with customer success, and make sure everyone knows what they would do in a real thing. Much like when we do a fire drill, we actually leave the building. In an incident response test, I want you to run through the test properly. And finally, learn from it. Look at your plan, figure out what you have learned and done from it, and then make changes to your environment. So the three things to get started with response, incident response in this case. Have a documented incident response plan. Now, it doesn't need to be a PDF in a drawer. It doesn't need to be fancy. If you're a Trello organization, you really love Trello, you do it there. If you are the type of organization who wants to do it in Markdown, in GitHub, I don't judge. Wherever you do it, whatever works for your culture. Test your plan with the real team and make it an application development security incident response plan so that you know what to do for those very specific incidents that only affect you, that you're going to be remediating. And review your plan frequently. Choose a different scenario each time and run through it. And then by the end of a year, you'll have lots of playbooks for different types of scenarios that mean that when something bad happens, you can respond quickly, identify things, verify it's a problem, contain them, and remediate. So we've had 5 things that we did in the pandemic we weren't even realizing were the key to us protecting ourselves from the software we're connected to, keeping our distance and protecting things from each other in case something bad happens, identifying problems through testing and vulnerability scanning, prevention through patching and prevention through protecting those things that cannot be patched, and responding with an organized incident response plan. To keep ourselves safe, we have to keep all of us safe. And that just doesn't mean our team that we're in, it means all of the software that we use every single day. So my challenge to you, and it looks like I'm perfectly on time because they've just given me the 2-minute warning, is are you ready to join the team of 30 million? And do you know why that team has to exist? Well, because in the world right now, there are 30 million software developers, but there are many, many pieces of software, millions of pieces of software, and they need every single one of us to take care of them. Because it's not about one big organization being the 2% at the cutting edge of this and doing everything they can to protect their stuff. It's about everyone working together so that even those in the least mature organizations, our tiny nonprofits, our little high growth companies, that shop that just got online because their business wanted to survive in COVID, all of us have to protect each other. And that means understanding how we connect to each other as an ecosystem, how our software connects to each other, and what happens when that goes wrong, so that we can protect ourselves in coherent and cohesive ways. So join me in the team of 30 million. Take these 5 steps into your world, and hopefully we can all be safer together. If you have any questions, now's a good time. The lovely Farhan will be looking in Hoover for that. And if not, you can contact me by email. It's up on the screen right now. You can find me on Twitter at lady_nerd. But remember the underscore, it's very important. The other lady nerd doesn't do security. Thank you so much.
Thank you, Laura. We have a couple of questions on the Q&A screen. I'm going to shoot that out to you. So the first question is, what's your experience with automating third-party libraries updates? Developers get cold feet in many cases as the application might break.
Yeah, and it's a really good question because we have, like, there are some cases where it's really safe to just update. It's a very small patch, it's a very small change. And if it's small and contained, then you can feel quite comfortable that you can test it significantly enough that once you make that change, it's fine. But the problem is that, you see some of the patches come through, particularly if you say in the Maven or NuGet environments, where patches come through for very big frameworks, and those patches themselves are huge. So you're looking at them having to review that and try and understand, have they documented in their changelog everything that's going to change in this? How coherently has it been tested before it was released? Now, I don't envy any of the developers at Microsoft, for example, because when they release a patch, they have to test it on every single version of every piece of software it interacts with. So, I feel your pain on it. What I would say is really understanding the scope and scale of the patch each time. So if that's your litmus test, how big is the library that's changing? If it's a node package, for example, and the code is 7 lines, just read the code. If it's something much, much bigger, you're going to need to work with your team to add the time into your sprints or into your workflow, really kind of dig into where has this changed and how confident I am that it's not going to break everything. Now, crudely, that could come down to diffing the code. Even if the changelog says it does X, Y, and Z, just diff it, see what changed.
Thank you, Laura. The second question is more of like a broader question. You might not be able to answer it in a one-liner. What do you think are the most important aspects of a security landscape? So if you're starting from a level 0, where should you be starting your security hardening first?
Absolutely. Now, I'm going to do a bit of a plug to something here. There's nothing commercial involved, but there is a white paper that I released a little while ago on how to do a security roadmap. So you can get started with that. But here's some things to start with. Firstly, there's some amazing resources in OWASP that you can get started with. So go check out the Application Security Verification Standard. That's going to give you the tiers of applications, sensitivity of risk, and a whole set of controls you consider. Even if you just get the level 1 controls in place, that's an amazing first step. Other thing you can consider is there are a number of free checklists and maturity models out there you can use. So OWASP has SAM, the Security Assurance Maturity Model. But there's also one, if you Google for CTO SaaS security checklist, there is a free checklist out there that can give you like a really step-by-step plan of which bits and pieces to put in place. Now, outside of those, to compress what they tell you into some little bits to think about. Firstly, start at the very beginning with protecting your accounts. One of the most important things you can do as an individual and as an organization, as a developer, is make sure that you have really good password and secret hygiene. Because even if somebody doesn't know you exist, your resources, such as your cloud hosting environment, access to your code, can be a really great avenue for compromising other things or for doing things like mining Bitcoin. So protect your accounts, multi-factor authentication being a must. Get used to reviewing the technology you're building from. So not just is it the right technology because it does the job, but is it a good choice for other reasons, including security? And also find your community. So security is huge. Like saying I do security in my applications is like saying I'm moving to Europe. That's a lot of things to consider. So find your community and find other people who've been along that journey who can share not just what worked, because that's exciting, but not that interesting, but share what didn't work. because they're going to tell you the things they failed at. And I've learned so much in my career by sharing honestly and openly what hasn't worked and what did you wish you'd done earlier. So try those.
Got it. And the next question is, what do you think software developers are missing in terms of security knowledge these days?
I think there's two sides to it. I think we focus a lot on syntax. Like every time we talk about security, we talk a lot about things like the OWASP top 10. It ends up in syntax. Here's how to not do cross-site scripting. Here's how to not do SQL injection. But for me, security doesn't begin at code. It begins at having a crazy idea. So, you know, there are people in the world right now literally trying to send people to Mars. It's amazing. It's a sci-fi future made real. But that didn't start with code. It started with an idea of, oh, I wonder if I can send someone to Mars. Security starts there. And I think the most important thing that we can do in dev teams, and the thing that we don't discuss enough, is how we can work with our product owners, our UX designers, our analysts, all of those roles in the software team, to really think about security at every single step. So are we designing our user interface that will encourage secure behaviors, or actually are we encouraging bad behavior? Are we looking at our architecture regularly? Are we doing threat assessment? Are we, if we're building machine learning systems, which is happening a lot now, are we considering where the data is coming and where our algorithm came from and how we can trust those? So it's looking beyond the syntax, which is great, and how security becomes one of the ilities. So with performance and scalability and accessibility and usability, and how it mixes with all of those. That's what I think we need for our developers. So less syntax, more systems.
That makes absolute sense. And to the last question, what was the impact of COVID-19 on cybersecurity?
I think we're an unusual industry for COVID-19. So many industries got really hurt by this, but you know, cybersecurity actually, you know, we had more to do than we've ever had because the threat landscape changed. And in fact, I think we'll see that change continue for a number of years. And that's because anytime something bad happens in the world and there's hardship, there will always be more instability and crime and people doing bad things. I think for me, what I saw was a lot of companies had to move a lot quicker than they were comfortable with. So they had to make decisions to survive. So they put technology online that they hadn't thought through. They acquired technologies and built from things they'd never used before because they had to do it quicker to support their team. And that made people very uncomfortable. It led to risk, but also it led to innovation. So I think, you know, yes, we introduced risks. And you know, if you look at the early days of Zoom, for example, there was a lot we learned very quickly about the security of online meetings. But at the same time, hundreds of thousands of businesses who had not really been internet first are now in the cloud and doing business online by default. And that's wonderful. So in a way, it's been a catalyst for some very exciting technology. And so for security people, we're now living in an age where some of the technologies we never thought would be built are being built and used. And so now we can embrace that. But we need to just be careful we don't burn out as a result of all of this rapid change, and that we stay healthy as this continues for probably many years to come.
Got it. Thank you. That brings us to the end of Q&A. Thank you, Laura, for the great presentation. This gave us a lot of insights and knowledge about security landscape. And if you have any more questions, feel free to contact Laura on the HUA platform. Thank you.
Bye. Thank you so much for having me. Bye.